Welcome to the fascinating world of Python classes. Python is a versatile and powerful programming language, and understanding classes is a key step in mastering it. In this journey, we'll demystify the concept of classes, which are the building blocks of object-oriented programming. Classes empower you to write more organized and efficient code by encapsulating data and functions into reusable units. Whether you're a complete beginner or have some programming experience, this guide will equip you with the fundamentals of object-oriented programming, or OOP, in Python. Object-oriented programming, often abbreviated as OOP, is a paradigm that uses objects to design applications in computer programs. At first glance, OOP might sound intimidating, especially if you're new to programming. But once you grasp the basics, you'll find it's a natural and intuitive way to think about programming. It's all about organizing your code into reusable units called classes. Classes are like blueprints for creating objects. These objects can then interact with each other, making your code more modular and easier to manage. Think of classes as blueprints. Just like an architect uses blueprints to design a building, a programmer uses classes to design software. These blueprints define the properties and behaviors of the objects created from them. For example, a class could define a car with properties like color and model, and behaviors like drive and stop. By using classes, you can create multiple car objects, each with its own unique properties, but all sharing the same behaviors. This makes your code more modular and easier to manage. Think of building with Lego bricks. Each brick is like an object, and you can combine them in countless ways to create complex structures. Each Lego brick has its own properties, like color and size, and can be combined with other bricks to build something larger. Similarly, in programming, each object has its own properties and can interact with other objects to create complex software systems. Classes provide the blueprint for these objects, defining their properties and how they interact. This allows you to build more complex and scalable applications. In the upcoming sections, we'll delve into the core concepts of Python classes, starting with a simple analogy to illustrate their purpose and functionality. We'll explore how to define a class, create objects from it, and use these objects to build more complex programs. By the end of this guide, you'll have a solid understanding of Python classes and be ready to apply these concepts to your own projects. Get ready to unlock a new level of programming prowess. Let's dive in and start exploring the world of Python classes together. Imagine you're baking a cake. You start with a vision of a delicious, mouth-watering cake that you want to create. But how do you turn that vision into reality? You wouldn't just throw ingredients randomly into a bowl and hope for the best, right? You'd follow a recipe. A recipe is essential because it provides a structured plan. A recipe lists the ingredients needed, like flour, sugar, and eggs, and the steps to combine them. It ensures that you mix the right quantities in the right order to achieve the desired result. This is analogous to how classes work in programming. Just as a recipe guides you in baking a cake, a class guides you in creating objects in your code. A class is like a recipe for creating objects. It defines the structure and behavior that the objects will have. It defines the data an object will hold, its attributes like ingredients, and the actions it can perform, its methods, like mixing or baking. For example, in a cake recipe, the attributes might be the ingredients, and the methods might be the steps to mix and bake the cake. Let's say we want to create a class to represent a dog. Just like a recipe, our dog class will outline the necessary components and steps. Our dog class would outline the characteristics all dogs share, such as their name, breed, and age. These are the attributes. The actions they can perform, like barking, fetching, or wagging their tail, are the methods. By defining a class, we create a blueprint that can be used to create multiple dog objects. Each dog object will be unique but will follow the same structure defined by the class. Each dog object we create will have its own unique set of attributes, name, breed, age, but they will all share the same methods defined in the dog class. This allows us to create many different dogs, each with their own unique characteristics but all capable of performing the same actions. In the next section, we'll take this analogy and translate it into actual Python code, showing you how to define your first Python class. We'll walk through the process step by step, just like following a recipe, so you can see how the abstract concept of a class becomes a concrete piece of code. By the end of the next section, you'll have a solid understanding of how to create and use classes in Python. You'll see how powerful this concept is and how it can help you organize and manage your code more effectively. So, get ready to dive into the world of Python classes, where you'll learn to create your own blueprints for objects, just like a master chef creating a recipe for a delicious cake. Stay tuned. Now that we understand the concept of classes, let's see how to define one in Python. The syntax is straightforward: Python class dog. Let's break down this code. 1. This line declares a new class named dog. Class names in Python are typically capitalized by convention. 2. This is a special method called the constructor. It's executed when we create a new dog object. The parameter refers to the object being created, and are the attributes we're passing in. 3. Inside the constructor, we assign the passed-in values to the object's attributes using 4 and. These are methods defined within the dog class. They represent actions a dog can perform. The method simply prints woof, while the method takes in parameter and prints a message indicating the dog fetched it. We've now successfully defined our dog class, complete with attributes and methods. In the next section, we'll explore attributes in more detail. Section 4: Attributes, the building blocks of objects. Attributes are like the characteristics or properties that define an object. In our dog class, and are attributes. They hold the specific information that differentiates one dog object from another. Think of attributes as variables that belong to an object. When we create a new dog object, we assign values to these attributes to represent the specific dog we're creating. For instance, my_dog equals dog, buddy, golden retriever, 2. In this code, we create a dog object named with the name buddy, breed golden retriever, and age 2. These values are stored in the and attributes of the object. Attributes allow us to store and access information about each object we create from a class. They are essential for representing the state and characteristics of our objects. In the next section, we'll shift our focus to methods and how they bring our objects to life with actions and behaviors. Section 5: Methods. Actions speak louder than attributes. While attributes define the what of an object, methods define the how. Attributes are like the characteristics or properties of an object, such as its color, size, or name. They give us information about the object, but they don't tell us what the object can do. That's where methods come in. Methods are functions defined within a class that determine the actions an object can perform. They are the verbs of our programming language, dictating the behavior of our objects. Without methods, our objects would be static and unresponsive. In our dog class, methods like bark and fetch. They represent actions a dog can take. For instance, a dog can bark, fetch a ball, or sit. These actions are encapsulated in methods, making our dog class dynamic and interactive. When we call a method on an object, we're essentially telling that object to perform a specific action. This is akin to giving a command to a real-life dog. For example, if we call the bark method on our dog object, it will respond by barking. For example, if we call bark, our buddy dog object will bark by printing woof to the console. This simple action demonstrates how methods can bring our objects to life, making them more than just data holders. Similarly, calling the fetch method will make Buddy fetch the ball. This interaction shows how methods can be used to simulate real-world actions in our code. Methods can access and manipulate an object's attributes using the self parameter. This is a special parameter that refers to the instance of the class itself, allowing methods to modify the object's state. This allows us to create dynamic and interactive objects that can modify their state based on the methods we call. For example, a method could change the color of a dog object or update its position. This ability to change an object's state is what makes methods so powerful. They enable our objects to interact with their environment and respond to different stimuli, just like living beings. In essence, methods breathe life into our objects, allowing them to interact with their environment and perform meaningful actions. They transform our classes from static blueprints into dynamic entities capable of complex behaviors. They are crucial for building complex and engaging programs. Without methods, our programs would be limited to simple data storage and retrieval, lacking the ability to perform any meaningful operations. Next, let's explore how to create instances of our classes, bringing our blueprints to life as tangible objects in our code. This process is known as instantiation, and it's the next step in our journey to mastering object-oriented programming.